All right, this is the Math 2, Unit 10, Lesson 9. These are our notes for 10.9. I put notes nice and big, expect you to do the same, so you remember this is not a worksheet to turn in. These are notes you keep in your notebook. Got it? Okay. The three functions that we've been this is the main function. That one right there is the main one that we've been graphing. But we've been comparing it with our rates of change to these type as well. This is called a what function? Linear, y equals mx plus b. You should remember that from last year. This is called the what function? Quadratic. You should remember that from this year. Y equals ax squared plus bx plus c. That is what form? Starts with an S. Standard. And it's nice to find the y-intercept. Okay, this is what function? What?
Exponential.
Exponential. You learned that one last year, correct? Or talked about it last year. Okay, so those are the three we're going to compare today. What you're going to see on the test is something like this. They're going to give you a chart, a T-chart of numbers, and you're going to look at the patterns and figure out if it is linear, quadratic, or exponential. I'm going to pause here and have the inside people quickly grab calculators. And when we're done today, if you can please pass them inward and the inside people can bring them back up. Okay, are we ready? Guys, so one more time, you're going to have charts like this on the test. You're going to have to look for patterns and then tell if it is linear, quadratic, or exponential. Okay, so what we're going to do right here is explain how to tell the difference. When the x values in a set of data pairs have a common difference, you can analyze data numerically to find the best model. Okay, so what is going on here? These numbers, the x value should always be increasing by 1, always. So -2, -1, 0, 1. Are those increasing by 1? -2, -1, 0, 1. Same. -1, 0, 1, 2, 3. Are those still increasing by 1? Yes? And that should always happen. On your x value, they should always be increasing by 1. Okay, looking here, how do I get from -1 to 2? The way you do that is, what is 2 minus -1? Is it positive 3? Yes? You do the bottom minus the top. What's 5 minus 2? What's 8 minus 5? Is 8 minus 5 also 3? Okay, so you're going to do that. That's the first one you should always check because it's the easiest. Bottom minus top, bottom minus top, bottom minus top. And then check if it is a common difference, like I'm adding 3 each time or I'm subtracting 2 each time. The y value has a common difference of, in this case, 3. A blank model fits the data. Does anyone know which one it is? If it's increasing by a constant number, is it linear, quadratic, or exponential? Linear is correct. Will somebody please close that door for us? Thank you. Okay, so common difference, whether it's +3 or -5, it's linear. Okay, this one, you do bottom, you would first check subtract, 2 minus 1, 1 minus, that's the first one you should check. But in this case, 2 divided by 1 is 2. 1 divided by 0.5 is 2. 0.5 divided by 0.25 is 2. Thank you. John? Or guys, with multiplication, it's a little easier to check as well. You're not going to have too many decimals like this. It's going to be a little easier. But what's going on here, there's a common ratio. You're multiplying by 2 each time. Make sense? It might be multiplying by 1/2. As long as you're multiplying by a common number over and over, it is a common ratio. Anyone know what that one is? It is exponential. And guys, why is it exponential? Think about it. Where's my exponential? If I had y equals 2 to the x, what's 2 to the first power? What's 2 to the first power? What's 2 to the second power? What's 2 to the fourth power? 2 times 2 times 2 times 2 is 2 to the fifth. We did that one yesterday. 32. So each time I'm doing this, I'm multiplying by an extra 2 every time. 2 to the third is 2 times 2 times 2. 2 to the fourth is 2 times 2 times 2 times 2. So look, it is 2 times 2, 4. 4 times 2 is 8. 8 times 2 is 16. Does it work? Yes? Okay, so exponential is when you're multiplying by a common ratio. Gentlemen at the end over there, I need you guys to stop the talking, please. Okay, this one is, to me, the more complicated one. I check for this one at the very end. If these two don't work, then I check this one. A second difference of the y values are all 4. So you go through that's not multiplying by the same number. So then you find the common difference. And are they the same? If it's -2, +2, +6, +10, are those the same? No. So what you're going to do first is check for these two. Is there a common ratio? Is there a common difference? There is not a common difference. There's not a common ratio. So what you do is you look for the common difference and you do it a second time. When you do it a second time, is there a common difference? Yes. If there is a common difference on the second one, then we say that one is quadratic. Questions? All right. We're going to quickly plot these points. So I want you to go through and plot number 4, 5, and 6. Let's just do them quickly. 0, 0, 1, 1, -1, -0.5, 2, and 1, 2, 3. Let's do the next one. 0, 11. 1, 5, 2, 3, 3, 5. And the next one, -4, -5. -2, -2. 0, 1, 2, 4. All right. Graph each set of points. Which model is most appropriate for each set? Linear, quadratic, or exponential? Okay, so we have those three to pick from. Linear is probably the easiest one. Linear has to be a straight line with a common rate of increase. Which one is linear? Would it be this one here? Even if the points are not evenly spaced out, they might be in this case. Would you agree it's still linear? Yes or no? Okay. These other two, I have to choose from quadratic or exponential. Quadratics are the only ones that have the U shape. There is a point there that's kind of hard to see. I go down and then I come up. Which one is this? What is it? Quadratic. Can you kind of see you're going to do that? It didn't give you any more, but can you assume it's going to go up like that? Yes or no? All right, which leaves this one. All I have is this. It doesn't U back up. It's not a straight line, which means it's going to be a what? What is it? Exponential. Questions? Okay. Now, at the end, which type of functions best models the data in each table? Choose from linear, quadratic, exponential, or neither. Okay. This is just a little thing that I do. I work with the positive numbers first, and then I look at the negative second. And I know I said to look for a common difference, but really it's easy to look for a common ratio. Am I multiplying by a common number to get from 1 to 3 to 5? Yes or no? No. Okay, so it's easy to look for a common ratio. Next, ask, are you adding a common number to get from 1 to 3 to 5, even if the number's negative? Yes. Am I adding a positive or a negative? And what am I adding to get from 1 to 3? To get from 3 to 5? Now what I do is I check if it works up here. Negative 3 to 1, if I add 2, would that work? Is negative 3 plus 2 negative 1? Yes or no? Let me try it again. Is negative 1 plus 2 equal positive 1? Yes. And then we already tested these. 1 plus 2 is 3. 3 plus 2 is 5. Is that a common difference or a common ratio? Difference is when I'm adding or subtracting. Ratios when I'm multiplying or dividing. I'm adding here, so what is that? Linear, quadratic, or exponential? Linear. Does everybody agree with that? All right. Next one, they're all positive. So I would check, again, I like to check for multiplying first. 1 times 2 is 2. 2 times 2 is not 5. 5 times 2. Okay, so is it being multiplied by a common number? All right, so we can rule that one out. Since they're all positive, let's just look. Remember, I do bottom minus the top. What's 2 minus 1? 1. What's 5 minus 2? What's 10 minus 5? And what's 17 minus 10? Okay, is there a common difference? Yes or no? No. Does that mean neither? Can I say neither right away? No. What do I have to look for? A second common difference, because that is a possibility. Just because it didn't work for the common ratio, and it didn't work for the common difference, I still have one more to try, so let's try it now. What's 3 minus 1? It's plus 2. 5 minus 3. And 7 minus 5. Are they all increasing by 2? Yes, if there's a common second difference, what do we call that? Quadratic. All right, next one. Am I multiplying by a common number? Can you guys check that first? That's easiest to check. Yes or no? No. 1 times 8 is 8. 8 times 8 is not 27. Does that make sense? Okay. 0 plus what is 1? Or 1 minus 0 is plus what? 1? What do I add here? 8 minus 1 is 7. 27 minus 8 is, did I hear somebody say it? 19. 64 minus 27 is, did I hear it? 37? Okay. Now, is there a common, we know there's not a common ratio. We checked that already. Is that a common difference? No. Before we check neither, we have to go one more time. What's 7 minus 1? What's 19 minus 7? That's a plus 6. 19 minus 7 is plus what? Anybody do that? 19 minus 7 plus 12. And what's 37 minus 19? You guys all have your calculators. 37 minus 19 is what? Is there a common second difference? Common second difference is like this, 2, 2, 2. Did that happen here? No. So what would we say? Neither. All right. Again, the first thing to check is if you're multiplying by a common number. Are we doing that on this one? 3 times, or 6 divided by 3 is what? Okay, so let's test it. Is 6 times 2, 12? Yes or no? And is 12 times 2, 24? And is 24 times 2, 48? So there's a common ratio. Which one appears the common ratio? Exponential. Any questions? Your test questions will be very similar to this. Can you guys handle that on the test? Yes? All right.